This video is going to cover all of C3 trig. The basic identities that aren't on the formula sheet are as follows. Cos squared x plus sine squared x equals 1, tan x equals sine over cos, 1 cos x equals sec x, 1 sine x equals cosec x, 1 over tan x equals cot x, 1 plus tan squared x equals sec squared x, and 1 plus cot squared x equals cosec squared x. Here's an example of how to use these new trig identities. Cosec 300 equals 1 over sine 300, which, after you put it on the calculator, equals minus 2 square root 3 over 3. And normally you just leave it in this form. The next thing you need to learn are the graphs. The sine graph and cos graph look like this, and it oscillates every 360 degrees. This is what the tan graph looks like. It's a bit different than the others, but still easy to use. You also need to learn how to draw the sec, cosec, and cot graphs, which are the inverse of the ones that we've just seen. This one is the sec x graph, and these can be used to show where different trig identities are equal, to test transformations and define ranges of equations.
A big part of trigonometry in C3 is proving that different equations are equal. This involves indices, cast diagrams, and lots of knowledge of identities. For example, prove that cot theta cosec theta over sec squared theta plus cosec squared theta is equivalent to cos cubed theta. So we'll take the numerator, cot theta cosec theta, and show that it's equal to cos theta over sine theta times 1 over sine theta. So this is equal to cos theta over sine squared theta. Next, we'll take the denominator, sec squared theta plus cosec squared theta, and that is equal to 1 over cos squared theta plus 1 over sine squared theta, and that is equal to 1 over cos squared theta sine squared theta. A good way to remember which one's sec and which one's cosec theta is the third letter relates to the first letter of the inverse of it. So the left-hand side equals cos theta over sine squared theta divided by 1 over cos squared theta sine squared theta. And then you can flip the second one and multiply it. So you get cos squared theta sine squared theta times cos theta over sine squared theta.
What are you doing? Okay.
Why isn't it rubbing out? The sine squared thetas cancel, so you get cos theta times cos squared theta, which is cos cubed theta, and that equals the right-hand side of the equation.
You're also asked to use cast diagrams to help you solve these equations. For example, solve sec theta is equal to minus 2.5. The limits being 0 is less than or equal to theta, which is less than or equal to 360. 1 over cos theta is the same as sec theta, so it also equals minus 2.5. So minus 2.5 cos theta equals 1. So cos theta equals minus 0.4. And when you put that in the calculator, theta equals 66.4 degrees. Because the last line of our equation was negative, it means it's in the opposite two quadrants. So it's in the sine quadrant and the tan quadrant. The two answers would be 90 plus 66.4, so 113.6, and 180 plus 66.4, which is equal to 246.4.
Remember these equations? One plus tan squared theta equals sec squared theta, and 1 plus cot squared theta equals cosec squared theta. We're going to use them now. So, if tan A is minus 5 over 12, and A is obtuse, that means between 90 and 180, find the exact value of sec A. We'll use 1 plus tan squared A equals sec squared A. So that means sec squared A is 1 plus 25 over 144, which is 169 over 144, sorry. Remember, this doesn't take into account the fact that A is obtuse. We square root 169 over 44 and we get sec A is plus or minus 13 over 12. We'll put that into our cast diagram and we get two lines, one in the cos and one in the sine quarter. And because it's obtuse, sec A is minus 13 over 12.
Here's another example of one of these questions. 4 cosec squared theta minus 9 equals cot theta in the interval here, shown now. You start by taking the 4 out. So 4 brackets 1 plus cot squared theta, bracket, minus 9 equals cot theta.
And that's because 1 plus cot squared theta equals cosec squared theta from that identity.
So 4 cot squared theta minus cot theta minus 5 equals 0. Now, if you factorize this equation, you get bracket 4 cot theta minus 5, close bracket, cot theta plus 1 in another bracket, equals 0. So that means cot theta equals 5 over 4 or minus 1. Therefore, tan theta equals 4 over 5 or minus 1. Using our cast diagram again, for tan equals 4 over 5, you get 38.7 for theta. So it would be in the or quadrant and the tan quadrant. And for tan equals minus 1, you get 45 for theta. So it will be in the sine quadrant and the cos quadrant. I don't know what the answers are.
So it will be 90 plus 45 is 135. And 360 minus 45, which is 315. So overall you get 135, 315, 38.7 and 219.
Because they're all in the interval that was first given.
Next we'll do the inverses, which are arc sine, arc cos and arc tan. The graphs of these are the same as the inverse, but reflected in the line y equals x. For example, the arc sine graph looks like this, which is just the sine graph reflected in the line y equals x. So, for example, solve arctan, find the value of arctan root 3 in the interval minus 90 or minus pi over 2 to pi over 2. So you solve tan x equals root 3 because it's the inverse. So you get pi over 3, or we'll show you on the cast diagram, pi over 3 in there, and minus pi over 2 there. Because it's in the interval minus pi over 2 to pi over 2, only the first value is valid. So we get arctan root 3 is pi over 3.